Hi, we're getting into solving systems of linear inequalities. So far we solved system of linear equations. We learned a lot of methods that I can use to solve the system of linear equations. But now we are getting into solving systems of linear inequalities. This is lesson 9.5. There is only one method that I can use to solve the system of linear inequalities. That's the graphing method. So it's not too much of confusion. So to know how to graph my systems of linear inequalities, I need to know how to graph my linear inequality. If we can go back to lesson 7.4, where we learned how to graph a linear inequality. So we are going to use the same concept here, and we are going to graph our linear inequalities. And systems of linear inequalities, I'm going to be graphing two inequalities on the same graph. Just like we graph two linear equations on the same graph, I'm going to be graphing two linear inequalities in the same graph. Alright, so let's take a look at how to graph this linear inequality. This is a recap of lesson 7.4. So I have 6x plus 3y is less than negative 12. So I have this linear inequality. To graph the linear inequality, first of all, I have to graph my boundary line. So to get my boundary line, I'm going to temporarily change it to an equation. 6x plus 3y is equal to negative 12. I'm going to temporarily change it to an equation, and I'm going to graph that line. So this is standard form. I can see that the coefficients evenly divide my constant number. So finding the x and y intercept is going to be easy for me. So x-intercept, I'm going to find the point x comma 0. So that means y is 0. So 6x plus 3 times 0 is negative 12. Or 6x is negative 12. Or x is negative 2. So my x-intercept is negative 2 comma 0. And my y-intercept is a point 0 comma y. That means my x is 0 for my y-intercept. So I'm going to plug in the value of x as 0 plus 3y equal to negative 12. This thing goes away. I have 3y is negative 12 or y is negative 4. So my y-intercept is 0 comma negative 4. So in my graphing paper, I'm going to go ahead and put those 2 points. My x-intercept, which is negative 2 comma 0, and my y-intercept, which is 0 comma negative 4. So I'm going to put those 2 points. I have all my x and y axes set up. So please use a ruler and please draw your graph to scale. So my x-intercept is negative 2 comma 0 and my y-intercept is 0 comma negative 4. So I got my points. Before I draw a line, I'm going to make sure what kind of line I have to draw, whether it is going to be a solid line or a dotted line. So when I look at my inequality is just a less than symbol. It is not less than or equal to or greater than or equal to. So it is just a less than symbol. So I'm going to have a dotted line for my boundary line. So I have my dotted line. Now I'm not done yet. I only drew my boundary line. Now I need to know which side has my solutions to this inequality. So I have a lot of points on this side of my line, and I have a lot of points on this side of the line. So which side is going to satisfy my inequality? So that's what I want to check. So I need to test a point. So the point that I'm going to test is 0, 0. The line is not passing through 0, 0, so I can use 0, 0. If 0 comma 0, if I plug into my inequality, if it works, if it makes sense, then all my solutions are going to be on the side where 0 comma 0 is going to be. But if 0 comma 0, when I plug it in, if it is not going to satisfy my inequality, then that side is not my solution. The other side will satisfy my inequality, and that side is going to have my solutions to the inequality. So I'm going to test my point 0 comma 0 I'm going to put it into my inequality. 6 times 0 plus 3 times 0 is less than negative 12. So this becomes 0, this becomes 0. 0 is less than negative 12. This is not true. That means 0, 0 is not a solution to my inequality. Since 0, 0 is on this side, I cannot have any solution on this side of my line. So my solutions are going to be on this side of my line. So this side contains the solution to my inequality, any point that I choose. So this is called my half plane. Wherever my solutions are to my inequality, that side is called the half plane. So this is what we saw in lesson 7.4 when we graphed our linear inequality. So it's the same concept that we are going to use today in lesson 9.5. In lesson 9.5, I'm looking at solving systems of linear inequalities. As we saw what a system is a group of things, right? So I have a group of linear inequalities. I don't have one inequality. I have two inequalities which forms the system. So I'm going to graph both inequalities on the same graph and see where my half planes are going to overlap. So this is my first inequality and this is my second inequality. So I'm going to graph each one of these inequalities one at a time on the same graph. So if I want to graph the first inequality, I'm going to write it separately. I have x plus 2y is greater than 2. So to graph this inequality, first of all I need my boundary line. So I'm going to make it into an equation and I'm going to find the boundary line. As you can see, this equation is in standard form and the coefficients is going to evenly divide my constant number. So I'm going to keep it as is and figure out my x-intercept and y-intercept. If it's not going to divide evenly, then I would change it into slope-intercept form and graph using slope and y-intercept. So in this case, my x comma 0, my y becomes 0, so this whole thing goes away. My x is equal to 2. For people who are still not following this, I'm plugging in y as 0, so this whole term goes away. I have x equal to 2, or my x-intercept is 2 comma 0. My y-intercept, I'm going to do it on the bottom so that I can do the other inequality there. So my y-intercept is a point 0 comma y. That means my x is 0 in the equation. So when I plug in x as 0, 0 plus 2y is equal to 2, or 2y is equal to 2, or y equal to 1. So my y-intercept is 0 comma 1. So I immediately go into my graph paper. I want to graph this inequality and get it out of the way. So I go to my graph paper. I have my x and y axis already set up. So my x-intercept is 2 comma 0 and my y-intercept is 0 comma 1. So if possible, please use two different colors so you can see the overlapping region clearly. So if you want to use color pencils, I suggest you use color pencils. So I'm going to use different colors. So my inequality is x plus 2y is greater than 2. So since it is just a greater than symbol, I'm going to have a dotted line. So I'm putting a dotted line. I'm not done graphing this inequality. I still have to shade a region to show where my solution lies. For that I need to test a point. So for me, the line is not passing through 0, 0, so I can test the point 0, comma 0 into my inequality. So if I put that 0, comma 0 into my inequality is x plus 2y is greater than 2. So if I plug in 0, comma 0, 0 plus 2 times 0 is greater than 2, or 0 plus 0 is greater than 2. 0 is greater than true. It's not true. Since it is not true, 0 comma 0 is not a solution. Since 0 comma 0 is on this side of the graph, I cannot shade that side. My solutions are going to be on this side of my graph. So this is the half plane for my first inequality. All right. So I graphed my first inequality. I got it out of the way. Now let's go to the second inequality. The second inequality is negative x plus y is less than or equal to 4. Here again, I want to first graph my boundary line for this inequality. So I'm just make it into an equation, negative x plus y equal to 4. So as I can see, the coefficients of x and coefficient of y is going to evenly divide my constant number. So I don't have to change it to slope-intercept form. I'm going to keep it as a standard form and figure out my x and y intercepts. So my x-intercept is x comma 0. So if I plug in y as 0, negative x is equal to 4 or positive x equal to negative 4. So my x-intercept is negative 4 comma 0. And my y-intercept is the point 0 comma y. If I plug in x as 0, this whole thing goes away. I have y is equal to 4. So my y-intercept is 0 comma 4. Now I go to my graph. I'm going to use a different color this time. My x-intercept was negative 4 comma 0. So I have negative 4 comma 0. And my y-intercept was 0 comma 4. I have 0 comma 4. And now when I draw my line, I'm going to make sure what kind of line I'm going to have, whether it is solid or dotted. Here I have a less than or equal to symbol, so that means I'm going to have a solid line. So I have a solid line. I am not done yet because I still have to see which side I'm going to shade. Which side is going to be my half plane, whether it's going to be this side or that side of the line. So I have to test a point. As you can see, my line is not passing through 0, 0. So I can plug in 0, 0, 0 comma 0 into my inequality. Negative 0 plus 0 is less than or equal to 4, or 0 is less than or equal to 4. This is true. So that means 0, 0 is a solution. So my solutions are going to be on this side of the graph. As you can clearly see, my half planes are overlapping in this region. In this region, I have 4 regions. 1 here, 2 here, 3 here, and 4 here. So my 2 half planes are overlapping in this region. Okay, so that's where my solution lies. So you can say my solution is in this region. As you can see, this region is bordered by the dotted line and the solid line. So I have solutions all in this region. The solutions on this line is included and the solution on this line is not included. Okay, so you have your solution to your system of linear inequalities. So this is the only method that I have for solving my linear inequalities. So you are solving both linear inequalities on the same graph and looking at where the half planes are overlapping each other. So that region is your solution. Sometimes they may overlap, sometimes they may not overlap, as we saw in special systems. So those kind of systems will have no solution. So we are going to do some problems in class based on those concepts too. So this is the basic idea that we are going to use. So come prepared. Thank you.